So I will start off with the
Thank you very much, Professor. That was very interesting where I understood it, but it is certainly a very specialized field. So I'm not sure how much the audience understood and whether they're going to ask any questions now. There should be more questions if you don't understand, guys. Um, but it seems amazing what you can do. Um, I wanted to ask you about the organic shell of the semiconductor core. What is that? Why is it organic? And where do you get it from?
oh sure. So uh through literature and through early work, and I've explained the triactyl phosphine oxide. So it has to be a kind of it can be a phosphine based material, and which is now we work on many amines. So we use long chain amines, and it can give you, firstly, with organic, it gives you uh, a vehicle to for the your quantum dot to be processed. So it can be either processed in a polymer or in a on a film, and so that gives you a kind of it more like a transport kind of function that allows you further manipulation of quantum dots. So it does cause problems as well, as we found out that it sometimes interferes with your property. So initially you want the property of the semiconductor, but now you have this organic shell which that can influence properties. So it has various functions. So the main function I would say is that it allows your quantum dots to be kept apart. If we don't have the organic shell, the material will coalesce. So you'll form the
Okay.
bulk. So you don't want the bulk material. You want actual nanomaterial. So so there's a lot of research on different types of organic material. So it's it can be silica, it
Okay.
can be uh, amines, thiols, water soluble water, dots as
Yeah.
well. So, yeah,
That is so interesting, bringing organic and non-organic chemistry together.
yeah.
And you need all of that of that knowledge. Um, Also interesting that you have to be so careful about the toxicity, um, and you can't allow the air to touch what you're doing. So I suppose you have the lab must be very specialized.
Yes, yeah, you have to use well, we use Schlenkline technique, so everything is kept under and done in a fume hood, with masks and with lab specs, and
Yeah.
with certain materials. Yeah, with cadmium, you have to be very careful how you handle cadmium because it's very toxic. Uh, and in terms of the application, and again, the organic halo, that also prevents the leaching of the cadmium into uh, in application. So if you're doing there is some work done on biological systems, so uh, it has to be leaching has to be prevented, and the organic
Right.
surface does also perform that duty.
Okay. Very
But in terms
interesting.
of safety, sorry, yeah, we've been lucky, touch wood, we haven't had any accidents. But yeah, we've been working on these materials for the past 20 years. Yeah, so we quite,
Wow.
we quite experienced in yeah.
Yes, obviously, yes. Are there other labs like that in South Africa?
Yeah, there are a few people doing this type of work. The University of Johannesburg, one of my ex-students, obviously,
Yeah.
and there's yeah, one ex-student in University of Johannesburg and one at Wits. So those are the only
Okay.
two I know.
Right, right. Um, sure. Very interesting. Are there ISO standards for for such labs, or is it beyond the ISO standards?
I'm not. Yeah, we do ours mainly for research. So I think if we do commercialize, we will have to look at that. Um, I mean, these are commercially available materials. The when I
Okay.
did my PhD, that work went into a commercial venture, and it's actually listed on the UK stock market. And there's a company that manufactures these quantum dots uh, for 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 TVs. For mainly Samsung, I think, is a company that purchases them. So they are, in the market at the moment. So, and obviously with commercialization, you would need ISO standards.
I see. Okay. This is very interesting for me because it affects, the ability to do research at all, and it costs money. So you have to have the resources to be able to establish such specialized spaces.
I should just
And
mention that, sorry, Madam Chair,
go for it.
that yeah, in terms of the funding, we are very grateful to the South African Quantum Initiative, and I think this work is just in its infancy in terms of the quantum application. What we have proven is that we can make quantum dots, but obviously we need to show the its ability or its effectiveness in being giving us materials that can be used or applied in the quantum space, and and
Yeah,
and so that's going to the next level now. So again, we've optimized our synthetic protocols to then make materials that we think are good quality, to give us good quality properties in terms of the photon, and then that can be taken up further for applications in quantum technology. I
I
think
see.
Bertus will,
Yeah.
there are three steps, and I think as I've said very at the beginning it's a long process. So I've basically highlighted the synthetic protocols, and he will talk about some of the protocols for the properties, and then we haven't really reached the application part as yet, but the device application aspect. But these study of the properties will lead to devices.
Right, right. Professor Revaprasadu, thank you very much indeed. Shall we hand over to Bertus van Heerden? Dr. van Heerden, are you ready? There, you're starting screen sharing,
Um,
I see.
yes, I think I'm sharing probably the wrong screen.
Oh.
Let me just. Oh, it's always something of a challenge. Um, Let me just do this, then it should. Um,
While you're doing that, perhaps I can return to Professor Neerish's biography. And I'm sorry I didn't introduce you properly, Prof. He got his PhD from Imperial College in London, and he's worked on developing routes for delivery of high-quality functional materials, as you've gathered from his presentation. Um, quite an illustrious bio there. And please have a read it on the event page. The link is in the chat. And Dr. Bertus van Heerden is a postdoctoral fellow at Department of Chemistry at UniZulu, and he completed his PhD in physics at the University of Pretoria. So, Dr. van Heerden, over to you. Okay. I'm not sure what is happening. Is that
I think
you disappeared for a bit? I don't know if I disappeared or whether you disappeared.
can you hear me?
Yes, can hear you.
I don't think I don't know if I'm sharing my screen currently.
We can see.
Yes, you're sharing your screen.
Yeah.
Yeah, so we actually
Okay,
see our images
can you
there.
see my slides now?
We see a field of stars, and it says application of quantum dots. Okay, you're repeating it. No. Our speaker has disappeared. Okay, well, while the Dr. van Heerden is trying to rejoin us, we are 64 participants at the moment, and you are reminded that you've got the Q&A to ask questions, and that there's information in the chat. There's a chat message from Spamandla Kumalu saying, greetings, thank you, Prof, for the wonderful presentation. I worked a lot with MSNPs. How do I actually tell if synthesized quantum dots if I synthesized quantum dots, because sometimes my results are in between. Again, how do I get clear scan of TEM? We struggle to dissolve them. We're using a new homogeneous precipitation from metal acetates and theoria ligand based. Thank you. So I don't.
Sorry, Chair, can I answer that? Can you hear me?
I'm sorry. Can you hear me now?
I think we now lost the
That is,
host.
we can hear you, but I think actually, I think the time for this part is up, isn't it? Or
Yeah, I guess.
I think we've lost the chair. Oh, there she's back.
Ah, Chair is back.
Apologies. Have you managed to start presenting, Dr. van Heerden?
Yes, I am sorry. My Zoom seemed to stop responding, and I had to quit it and
Right, it
again.
happens.
Yeah, if we need to move on to the next speaker, that is okay. I apologize for the malfunction.
Okay, let's see if we have a time later in the program. If you could stay tuned, that would be great.
Okay.
Okay. Right, next up we have Professor Andrew Forbes, Distinguished Professor at the University of Wits and Director of SAQT, talking about Towards an Intelligent Quantum Camera. Professor Forbes is also a double award winner from NSDF, the NSDF awards, and many other awards as well. So please read his bio to get to know what his background is. But we'll give the floor straight to him. Welcome, Andrew.
Great, thanks, Jesse. So I guess you can see my slides, right?
Yes.